Welcome to the HVM networking video series. This video series is broken out into two volumes, pre-installation and post-installation. This is volume 1, video 3, planning your HVM installation. In this video, we'll be discussing the following topics. What are some common networking scenarios? What should you consider based on your situation? And how to configure the host networking based on the given scenario. Okay, let's get this out of the way up front. Networking is hard. It's the hardest part to get right the first time. The goal of this video is to help you understand the things you need to know before you start the installation process. Proper planning up front can negate a lot of rework later. Before installing the HPE HVM OS and configuring it for use, you need to make sure you have answers to some fundamental questions about the networking environment you're installing it in. Things like how many interfaces are on the host, what VLANs will be used and for what purpose, what storage network capabilities will you have, iSCSI or Fiber Channel, and the interface bonding plan. Let's look at some possible network configurations. The scenarios we're looking at are based on the physical layer. How many physical interfaces are available for configuration? Within each scenario, there are multiple possible configurations based on environment need. Scenario 1, Converged Management and Compute. In this scenario, you would have 4 total NICs on the host, preferably spread across 2 network cards to give you actual redundancy. This is likely to be a very common scenario based on the NIC count in the host. To go along with this redundancy idea, you would preferably have 2 separate network switches as well. Then you can direct 1 storage lane to one switch and 1 storage lane to the other for a solid redundant multipathing solution. Likewise, you'll direct 1 VLAN trunk lane to each switch. The VLAN trunk lanes will be bonded in an active backup configuration to give you the fastest failover possible in the event of a switch or network card failure. In such a scenario, the bond will handle the VM and management traffic failover, and multipathing will handle the storage lanes. And of course, you can utilize LACP in this configuration as well. So, how would you configure this scenario with native VLANs? So let's look at this first as if you're configuring this when you have a native VLAN on the trunk port and the storage ports. So we recommend having only the storage VLAN allowed on storage ports to ensure traffic isolation. This means that the network switch is tagging storage and management traffic for you, and you don't have to tag it yourself. This allows you to put your IP address directly on the interfaces and bond. The compute traffic will be tagged by Open vSwitch and managed by the manager. When we run through the installation wizard, here's how we can set this up. First, we create the bond called bond 0 using the correct interfaces. Then, you'll add the management IP address for that host into the IPv4 configuration on the bond directly. Now, I want to make a point here. These IP addresses that I'm using here are examples. That's it. If you try to use these in your environment and you are not set up exactly how this environment was set up, you're going to have a bad time. So for the storage network, you just make sure you put the correct IP address on the correct interface for each storage network. You'll notice that there's no gateway, name servers, or search domains in the configuration for the storage interfaces. It's general best practice to have your storage networks be non-routable for security reasons, and that's why it's set up this way. If your storage networks need to be routed, then you can put that info into the form. Now your network config should look something like this. Again, not exactly like this, these are examples. Your interfaces and IP will be different. In this scenario, bond 0 will be both your compute and management interfaces at cluster configuration time. So let's look at a quick demo of this in the installer. Alrighty, here's our demo on the Converged network setup with native VLANs. First thing we do is we create our bond, and we're going to set this to active backup in here, and we're going to create. All right, we've got the bond in existence, so now we need to put an IP address on it. We put it directly on the bond because that is handled, the VLAN tagging is handled by the switch. Talking and typing at the same time is not one of my strong suits. Put 139 for that. 168.3.1 will be the gateway. I'm not going to worry about the name servers or search domains, but you put those in as needed. And I'll go ahead and save this. Okay, and in that bond, I stuck ENS 18 and 19, and you can see they're enslaved to bond 0. So this will be our storage. Storage 1, do manual here. Let's be 192.168.90. and 192.168.9.1, 139. No gateway, no name servers, no search domains because storage traffic is non-routable in this environment. We'll do one more. 10.0. Look at that go. Then 192.168.10.139. Oops, what did I do there? 10. Missed it. There we go. And save. There we go. So that's what it's like to configure your environment when you're using converged network setup with native VLANs. Okay, that was fun. But what if you can't use native VLANs in your environment? Let's look at a scenario that covers exactly that. When you have no native VLANs, you actually need to create the VLAN tags on all interfaces because now the switch is not doing any tagging for you. Your IP addresses will go on those VLAN tags. Lock this in your mind for later, but you can see here bond 0 becomes your compute interface and bond 0.3 will become your management interface when configuring the cluster later. As you can see here, we're adding the IP address to bond 0.3 like we stated. And you don't set an IP address on bond 0 when using a VLAN tag for management. Bond 0 will be used for the compute traffic. Again, this is an example. Your configuration will vary. Now you'll fill out the information for storage in much the same as in the other example. You'll be utilizing the VLAN interface as opposed to the direct interface. So ENS 20.9, ENS 21.10 for VLAN 9 and 10 respectively on those interfaces. And in this picture here, you can see that the IP addresses are all on VLAN interfaces. Let's look at a quick demo of this in the installer. All right, demo 2. This is converged network setup without native VLANs. So the first thing we need to do, again, is create our bond. So there we go with that. We'll select our active backup, and I'm going to create. Now the bond, since we're not doing native VLANs, there's no way for the system to know what VLAN tag needs to be attached to the networking. So we're going to go ahead and add that VLAN tag, management network of 3 here. And on that interface is where we're now going to put our network information. So 3.0/24, see if I can do better this time. 39, our gateway, 168.3. Okay, again, we'll skip over those for now, but you're going to put them in for your environment. Now, that's for the management. Now for each storage VLAN, we need to go ahead and put this in. So we've got R9, and you go to manual, to 168.9.0. So it's all very repetitive. This demo is going to be very repetitive. And again, no gateway or anything like that on the storage interfaces because it is non-routable. VLAN tag of 10, create, and here we go one more time. Manual to 168.10, 0/24. Man, that is just messing me up this morning. There we go. And save. Okay, so now you'll notice from the slideware, very similar here. So each interface, the bond and each storage interface are now sitting with a VLAN tag, and that VLAN tag is where the IP address went. Okay, so what about native VLANs for storage? Let's do one more look. This time, we have a default VLAN for our storage networks. They're isolated, and the switch port only allows traffic from that VLAN through and tags the traffic for us. So they can have the IP address directly on the interface. But we don't have a native VLAN on the trunk port, so we still need to configure a VLAN tag and put the management IP on the VLAN interface. Hopefully you're picking up the theme here. Where the IP address goes on the host is dependent on how the networking is set up on the switch. Now this should look familiar. The IP address is being placed on the bond's VLAN interface for management. Now we've seen this exact same configuration before as well. The storage IPs are directly on the interface this time because we have that default VLAN and we don't have to tag it. And here you see that we have the management VLAN with its IP address and the storage interfaces have their IPs directly on them. Let's look at a quick demo of this in the installer. All right, so for this one, our converged network setup with native VLANs for storage only, meaning we do have to tag our management network, but we don't have to tag our storage. This one's pretty simple. We'll go ahead and once again, we're going to create our bond. and active backup. Okay, now we have our bond for management. But because we don't have a native VLAN on our management network, we do need to not do what I was just about to. We need to go add our VLAN tag and create. And on the VLAN, here's where we add our address. Again, same as always. So we're on our .3, let's see, .3.139 and 3.1. Go ahead and save that guy. Now, because we do have native VLANs for our storage network, and hopefully that's the only VLAN allowed on that network, we can just go ahead and put this directly in to 168.9.0/24, 168.9.139, and again, no gateway, same as always, and another 4.10 to make sure we have our solid multipathing, 222.10.0, and 192.168.10.139, and save. So that's what it's going to look like for us when we have native VLANs for storage, but not for management. And you're going to see the pattern throughout all these demos. It's very much the same, just depends on what that environment looks like, what you're allowed to do in the environment you're installing in. Let's take a look at our next scenario, decoupled management and compute. Now, if you're lucky enough to have 6 or more NICs on your host, then you can separate your management and VM traffic. The overall configuration will be basically the same, except you'll create a separate bond with 2 of the interfaces for the VM traffic. Once again, it's preferred that the bonds are spread across multiple network cards. In this configuration, you'll separate the storage lanes as before. Likewise, you can direct one VLAN trunk lane to each switch. The VLAN trunk lanes will be bonded in an active backup configuration to give you the fastest failover possible, or LACP if you have that configured in your environment. So let's revisit the native VLAN setup in this configuration. You'll notice that it's mostly the same, just with the extra bond for VM traffic. One thing to note in this configuration is it's easier if you can have the management network be the only VLAN available on that trunk to isolate the traffic. Then there's no need for VLAN interfaces directly for storage or management, and the compute bond doesn't get an IP address anyway. Since we covered off the general settings in previous examples, we'll go straight to the end state now. And here's what the resulting configuration looks like. You'll notice that we're using the bonded interfaces directly and have not created any VLAN interfaces. You'll also notice that we don't need a native VLAN for the compute trunk because it's tagging all the VM traffic external to that. So let's take a quick look at this in a demo. Okay, buckle up. This one's going to be completely different. Actually, not really. It's just going to be a little different. Here we have our active backup bond for management. And because now we have 6 interfaces, we have our fully decoupled networking setup, we can actually create 2 bonds. One for management and one for VM traffic or compute. Go team. Now, we are using native VLANs in this particular scenario. So again, we only have to put the IP address information on the interface directly. The interface being the bonds here. So we got that. 192.168.3.139 because I have to talk and type at the same time apparently. Go ahead and put that in. All right, on the second bond, what do we put in for this IP address? Nothing. This bond is for VM traffic and all your VLAN tagging and everything should be handled on the back end. So nothing goes in here, but we still have our storage networks. Let's do these in order. Okay, go ahead and manual 192.168.9.024. I'm sure you're getting the point by now. But guess what? We're going to go through and finish this up anyway because I don't like doing things in half measures. So also I still can't talk and type. You'd think by now I would be better at it, but I'm not. All right, so save this. And now fully decoupled, separate management and compute interfaces, bond 0 and bond 1. And then storage traffic on their own, utilizing native VLANs. And again, if there are no native VLANs, well, if you can't use native VLANs, then you need to create VLAN interfaces for the storage and management networks. Again, not for the compute, because compute does not need an IP address. Here's what that resulting configuration would look like. All right, one more quick demo to really drill these points home. Okay, this is definitely the messiest, but could possibly be the most common one. I guess we'll find out as time goes on. But 6 interfaces, no native VLAN. What we need to do here is create our bonds, add our VLAN tags for our bonds, and then IP everything the way we need. So, starting from scratch again, 1, 2, go into bond 0, active backup, and create. Create bond 2, or bond 1, I guess, the second bond, and we're good to go there. Okay, from here, it's really not any different than the no native VLANs when you're using the converged. You just ignore this bond. You don't put anything on it because you don't need to IP the thing. So on bond 0, we'll add our VLAN tag, VLAN tag 3, and because I just feel like doing it this way, because I do, we'll do all the VLAN tags first. Okay, so now I have all of my VLAN tags for my interfaces, and we will go IP them. Okay, so on our VLAN 3, our management, we'll go ahead and set that to manual. Can anybody guess what this is going to be? That's right, 0/24. Well, what's the IP? Have you been paying attention? That's right, 139. Okay, we now have our management IP address on bond 3. Bond 0, what IP does it get? None. Exactly. So we'll come back down to here. And for VLAN 9, 2.168.9.0/24, and the same IP we've been using this whole time. I know it's different than the slides, but that's because things have changed since I made the slides. And on our next one, go here, and we do 10. 10.0, 2.168.10.139. And again, these are my IP addresses, not your IP addresses. Don't follow this exactly. This is just to give you the idea of what it should look like overall. But now you can see this is a little bit messier. It's a whole lot more on the screen, but we do have our bond 0, which has a VLAN tag on it, which has our management IP address. We have bond 1, which has nothing on it. It just passes all of the traffic, so there should be that trunk of VLANs coming into it from the switch. And then VLAN 9 on storage network 1, VLAN 10 on storage network 2 with their respective IP addresses. Okay, let's look at our last scenario for this video, wholly converged networking. You may have a scenario where the hosts only have 2 network interfaces. You can still make this work by bonding both interfaces together and creating VLAN interfaces on the bond for each service. And let's be real, if your hosts only have 2 NICs, there's a possibility you only have 1 switch as well, but we're not going to worry about that here. When designing a wholly converged network, you should avoid using LACP bonding for iSCSI storage interfaces if you also intend to use MPIO. LACP treats the bond links as single logical interface and performs its own traffic distribution, where MPIO expects to manage multiple independent network paths. Because the 2 mechanisms attempt to control traffic flow simultaneously, they interfere with each other and prevent proper multipath operation. With that said, let's look at what this configuration could look like. We'll start without native VLANs this time, because why not? Once again, we have bond 0 for our 2 interfaces. What we do then is create a VLAN interface for management and each storage network. We can then IP those interfaces as necessary. And once again, this can all be done during the installation process. Now you'll still IP things the same way. Each VLAN interface gets its own IP based on its need. So with this setup, what do you think? Can you use native VLANs? Well, the answer here is each switch port can only have a single native VLAN, so you could do a native VLAN for your management network if you want. Once again, we would have bond 0 for our 2 interfaces, and then we would create a VLAN interface for each storage network, and that'll handle tagging for the storage. Then you IP those as necessary. Now for the management network, we don't create the VLAN interface, and we would configure the management network as the native VLAN on the switch, so the switch will take care of the VLAN tagging for us. And from there, you still IP things the same way, right? So the IP address for each interface goes on those VLAN tags. So you got the bond 0.10 for your storage and 10 and 9 for your storage, and then bond 0 for your management. Now, we get asked this quite a bit. If I only have 2 NICs, can I physically separate the traffic? Well, what happens if you do something like this is you have 0 redundancy. So it's better to take the performance hit than to risk having a total catastrophe. So in my opinion, it's better to just bond your interfaces and send your storage out over a single VLAN or 2 VLANs if you want to do multipathing. So let's look at this one more time with a quick demo. All right, one last demo in our Death by Demo series here. We are going to do the wholly converged. So we've only got 2 interfaces on this server. What do we do? What do we do? Do we put an IP address here and an IP address here? No, we don't. We create our bond. Active backup. Why do we not just separate the traffic? Because if one of those NICs fails, we lose all kinds of stuff. Catastrophic failure. Better to just have a little bit of latency. We got an environment like this, it's probably not going to be getting hammered too much anyway. So let's go ahead and on our bond, let's assume for this one, we've got our native VLAN set up. So VLAN 3 is being pumped through on both of these interfaces as the native VLAN. So we'll do 192.168.3. What is it? Yep, 0.24. And here's our IP and our gateway. Save. Great. That's awesome. But I have storage traffic. What do I do now? Well, on this bond, that's where we're going to create our VLAN 9 and our VLAN 10 interfaces, and we will go IP those here. So we'll do that. 2.168.0, and this one 2K. No gateway. Almost tricked myself there. And here we go. One more. We can do this. We can make it all the way through. Make it almost all the way through without messing it up. So close. Got too excited. Here we go. 10.139. All right. So in wholly converged, this is what you're going to look like if you're using native VLANs. Now you're only going to want to do that for management, but let's say you don't have any native VLANs in the environment. We'll just go ahead and set this back to disabled. We'll save that and we'll create a new VLAN tag for our management. Yeah. Very, very much like everything else we've been doing, right? It's just the amount of NICs that you have determines where the IP interfaces go in conjunction with whether or not you are utilizing native VLAN tagging. And there we go. 2.168.3.139 and our gateway. Oh, there we go. Hey, made it through. Okay, so wholly converged networking with and without native VLANs. In this video, we discussed the following topics. What are some common networking scenarios? What should you consider based on your situation? And how to configure your environment based on that situation. Thanks for watching.